closer to the item. Yes?
This is a bit intimidating, isn't it? We can see it counting down. I'm going to go quite quickly as well, for a different reason from Alan. Alan said he had too many slides. I have exactly the right number of slides, but not enough minutes. So, this is going to be focused a little bit around the Met Office, but I think we share a lot of these things with... there we go. Here are some words that characterise National Met Services requirements. Starts with deep science. Without deep science, we don't get anywhere. There are lots of words here that aren't on here, like great observations, data, which people referred to earlier. But all this does is show that there isn't one aspect in our work that you can improve and solve the problems. There's a massive array of different disciplines, different science disciplines, different ways of working that we need to adopt to make the whole thing work. And particularly at the moment for Met Services, a lot of people are being squeezed for money. If you don't have the money, you can't invest. Without investment, you can't improve. And I spent half of my life worrying about that kind of stuff. This is the Met Office bow tie, and I'm going to show you this because it gives you the overall strategy for our organisation. And there are one or two of my colleagues in the room going, oh bloody hell, it's the bow tie again. But once you've seen this, you'll understand. One of the fantastic things about Met Offices and Met Services is that we have the reach from deep science right down to individual impact on people's lives. And at Met Office we sit with around this fulcrum of huge operational resilience. 4.5 million forecasts a day, processing more transactions than the whole of the British banking sector does, based on fantastic science and big supercomputing capability, extensive observations. But then we reach right out into the far reaches of long-range science. And there are some areas in our organisation where the world expert is in our organisation. But the further out we go to those frontiers of science, the more we collaborate with others. And there are some examples here of collaborations with National Met Services, with academic institutions, with certain research centres. And that is a huge, those collaborative skills are at least as important as scientific skills in the way we manage our affairs. And so, of the 270 academic papers that were published by Met Office scientists last year, 70% were co-authored with other science institutions. We cannot do all the science we need to do in isolation without extensive collaboration. But the same occurs in the delivery of our services. We reach out to individuals in our country. And there's a lady from the east of England who rings up every week to check whether it's a good day for washing her clothes. Now, it's a crazy example, but the fact is we reach millions and millions of people every day who are deciding large-scale and small-scale, making large-scale, small-scale decisions, and we have to be able to deliver the benefits of our science to them in whatever context they're working. Now, it's a generic problem, and you'll see here that I've put, and further out we go there, we also work and collaborate with others, whether it's resilience managers, broadcasters, doesn't matter who it is, we have to work collaboratively with those people too. There is an opportunity that we have identified for Met Services. Most private sector science is much closer to that customer frontier, and a long way from the long-range science. And most public sector science, and I include universities in this, that science is much closer to that science frontier, but very often a long way from application. And that doesn't matter too much, except that 100 years ago, most of the, 2/3 of the world's long-range science was done in the private sector, and there is therefore motive and mechanism for getting that science out into application and to the benefit of people. And now, 2/3 of the world's long-range science is done in the public sector. And there is what our American chums call the valley of death between a huge and fantastic investment in science and the delivery of benefit to the world. And one of the things in the meteorological community that we have is we have experience and expertise in taking that science and delivering the benefits. And we can help ourselves and others deliver that. Let me talk about three things. First of all, in deep science, around the science. First, and they're talking about seamlessness. Alan's referred to this in certain scales. One of the benefits that we enjoy in the Met Office is having weather and climate in the same house and transferring skills, getting greater efficiency across those timescales. established expertise in short-range forecasting and established expertise in climate. But the sweet spot in some ways is then that seasonal to decadal forecasting, where big strategic decisions are made by countries, businesses, all kinds of organizations. And with an ability to invest consistently in new areas and developing areas, we are beginning to prove that areas of prediction that were previously considered impossible are becoming within the reach. Big data exchange, big science, big supercomputing capacity, and scientific endeavor brings those things within reach. And that gives another hint to the way we work. My own philosophy is that science, over the last 200 years, we look back 150 to 200 years, scientists, great scientists were polymath. They had lots of sciences. They were doing engineering and chemistry and physics all at the same time. And then as years have gone by, science has specialized and they have become somewhat distant from each other. And now with huge data exchange, big modeling capabilities, there is an opportunity and a possibility to bring those sciences back together. And again, in the Met services, we have expertise and experience in doing just that. So our job is not done just by understanding weather and climate. Our job is only done if we have extended into impacts, and that requires a joining of sciences and applications right across boundaries which have been created in science over the last 100 years. And then there is the benefits of direct investment in things that we believe are important. And I'm giving you two examples of where investment has proved beneficial and shows how we push down the frontiers as often as we can. The two charts on the left are an example of some forecasting we did for the Olympics last year in the UK. And this is a coupled 333-meter atmosphere model and a 250 wave model. And this was for the sailing event in the Olympics. Now, computationally a bit expensive, but fantastically revealing and interesting. And I used to joke and say that if one of the sailors coughed, we could probably model the impact, because here you're getting right down into fantastic detail in quite complex situations. Another example from a longer range, we all know in this community that predicting blocking frequencies for longer range forecasting is very important. And you can see at the bottom here, this is for winter periods, observations, the pattern of blocking periods over the UK and Northern Europe. And the previous models were a long way from predicting those blocking frequencies. Now with the new model, much better identification, and that gives us, for winter periods, over the last 14 years, a correlation of forecasts to outcomes of 0.6. 0.6 is massively better than any previous historic best. It was 0.2, and a lot of centres only get 0 correlation. You're beginning at 0.6 to get real information for strategic planners to be able to use. And to Alan's point earlier, it might not be useful for specific events, but in that get ready type phase, it really does begin to help people plan their affairs. In terms of challenges for us in the meteorological community, there are many, but here are some. Constant need to demonstrate value. I've seen in recent years Met services around Europe cut in half, reduced by 1/3 because of the financial crisis. And ours is a long science, and chopping and changing, investing and disinvesting really doesn't help. So the ability to demonstrate value, both to individual customers and to governments and to people who pay for our services, is vital. Now sometimes we use socioeconomic studies to show this, and these are imprecise things. How you value a life not lost, I'm not sure. But we have to continuously push to demonstrate the value of our organisations and why countries and businesses should invest in them. Clear joined up communications of risks and impacts, and I'm going to show you some examples, and when Andrew stands up he will show you some others. But when in extreme events people get information about the advance of an extreme event, the first thing they do from our studies is seek to corroborate it. So they look, they go and check. And if there is a multiplicity of interpretations and versions of what's likely to happen, they do not act. It's only when messages are consistent between themselves and over time that people actually take action and respond to the warnings. And we have to be aware of that. We can't just say, here's the weather, We have to say, here's the likely impact to you, and this is why it's important that you take action. Improving the understanding of potential. Sometimes we in the community fall into the trap of believing just because something is obvious to us, it ought to be obvious to everybody. And that's not the case. Most people, particularly of my generation, have been brought up in terms of whether to look out of the window and decide to take an umbrella or not. I spend half of my time trying to convince people of the potential of a deeper understanding of the use of weather and climate intelligence to avoid food waste, to live better lives, all of that kind of stuff. And we are still in weather just scratching the surface. And if we consider that the use of weather science is young, then the use of climate science is still embryonic. There's a massive amount of progress to do just to get people's understanding of what they can do with this and how they can improve their affairs as a consequence. And that falls to us as well. And then contextualization is really important. We used to teach our forecasters not to interpret the weather. Now we fire them if they don't. And that's because saying there's a high wind doesn't help people prepare for what the consequences of that high wind might be. Again, forces us to understand much more the impact and contextualization. So let me illustrate the contextualization. One of my colleagues runs a rugby club in the winter and a cricket club in the summer. For those of you who don't understand cricket and rugby, it doesn't matter. One's a game where you play regardless of the weather, and the other one, slight weather disturbance, stops the game altogether. And the Thursday afternoon phone call to say, is it going to rain on Saturday, has a completely different interpretation. So then when you get into talk about farmers or sailors or pilots, all of those things have detailed consequences and context that you need to understand before we can deliver an appropriate weather forecast to their needs. And we need to get continually better at that. Here's an example of the kind of pattern you've seen already in previous speakers, but we have a system. I'm going to develop this a little. We have green, yellow, amber, red, and the amber is the yellow is be aware, be prepared, and take action. And I'm going to use a couple of examples here which show how that works. And the first one is about an event in Scotland, and since Andrew Lawrence is going to talk about this quite a lot, I'm going to leave it mostly to him. But the issue here is, by working with the users of our intelligence, we were able to help avoid massive risk and disaster. And this bus here is a school bus in Scotland which was turned on its side. Nobody was hurt because the school bus was empty, because the Scottish authorities had closed the schools and the bridges. And if ever you need an example of how weather forecasting can really help avoid disasters and save lives, you've got one. Here's another example of collaboration working. In 2007 we had some dramatic floods in the UK for which we handled not very well. In the UK, the responsibility for flood forecasting was not the weather forecast, that's the Environment Agency, and we had a responsibility for forecasting extreme weather. The Environment Agency was responsible for forecasting floods at 2 hours' notice. We had a responsibility for forecasting extreme weather as soon as possible. And therefore, sometimes we could see things happening 5 days ahead, and because we weren't working together, we weren't delivering good intelligence to both the responding community or the general public. We have now brokered a collaboration. We have a flood forecasting centre where hydrologists and meteorologists sit, they're cross-trained, they represent 2 organisations, and they work together. And I know around different countries, around Europe and around the world, there are different borders drawn between different organisations when the impacts of their work ought to be joined together more effectively. And the only way we've found of doing that, because we can't restructure the whole of British government, much as I sometimes would like to, we join across boundaries to make sure that we deliver a service that is worthwhile. Another example of collaboration which emerged from the volcanic ash incidents a few years ago, we are a volcanic ash advisory centre. We have the fortune or misfortune of being responsible for the Icelandic volcanoes. The first time we had a major eruption, it took us several hours, almost a day and a half, to find the expert on those volcanoes in British Geological Survey, who has responsibility for volcanology and landslips and earthquakes and tsunamis. So the service didn't get off to a great start because we couldn't interpret, we couldn't understand the source and what the height of the eruption and what the contents was. So the next time we had an eruption, it took 2 minutes because we knew the people, we built the relationships, and the British Geological Survey have a desk in our office that allows us to join together to give much better advice to the public. And we extended that concept and created a natural hazard partnership. So you can see some of the brands and logos of a range of organisations in the UK who have different responsibilities for different natural hazard conditions. And we all work now together in a partnership as seamlessly as we can to deliver a more complete service. And as somebody raised the issue about Fukushima earlier, there was an earthquake, tsunami, a flood, weather, and a radioactive incident. That requires, in lots of countries, collaboration between many people, even if the scientists have some things in common. So we have a natural hazard partnership which now begins to publish composite pictures of natural hazards. And in the bottom left-hand picture, you can see a hazard map. And most countries have hazard maps of some kind. This one takes into account the roads, the conditions of the roads, the kind of traffic that normally travels on the roads, what kind of a day it is, a business day or a weekend, what time of day it is it a rush hour or not, what's the shortest diversion time, and we negotiate and agree impact assessments with our customers depending on all of those factors and the weather for which we are initially responsible. And only that extension really delivers, I think, the benefit for the fantastic science that we do. Here's another example of a landslide warning, the first one we did in collaboration with the British Geological Survey, and this was a service for walkers in dangerous terrain. Another example of collaboration is a space weather service that we have initiated in collaboration with NOAA in the US, but it includes 5 other partners in the UK to begin to develop a space weather service that is useful to people, whether they're in aviation or utilities companies. Again, not something we could have done on our own. And then we've extended that concept beyond natural hazards. So we have an environmental science service partnership because there are many things which don't just depend, that we have science and expertise for, that don't just depend on extreme events, but help people's understanding for managing their affairs in general conditions. So whether you're a farmer trying to decide to plant or to harvest or to use insecticides or growth promoters, whatever it is, an understanding, a much greater understanding and partnership across that boundary between us, soil scientists, us, and agricultural scientists, us, and the agricultural community is really important. And this was, I was in Singapore a little while ago, and I met a marine geologist who had just been to Vietnam, and he had been doing some, somebody had invested $800 million just north of Da Nang on a golf and holiday complex on the coast. And this marine geologist had dug back from the beach and discovered that every so often there was deep ocean sand along the coastline. And that indicated to him that this coastline was subject to tsunami every 10 to 12 years. Now, as a former businessman, I would have much rather have had that indication before I spent my $800 million on building this complex, which was then at risk. And there is science in the world that just doesn't get used. And part of our responsibility, at least in our domain, is to push that science towards people who can use it. Broad services, we touch 4.5 billion forecasts a day, hundreds of thousands of people, sometimes millions. And so we have developed increasing skills in communication, not just in the words of communication, because we talk about probabilities and uncertainties quite a lot ourselves, but most people have difficulty understanding how to manage probabilities and uncertainties. And we've discovered, for example, that where people have an intuitive understanding of the subject matter, they process probabilities very well. So if you ask a football fan in the UK whether Manchester United will be in the top 3 of the Premiership at the end of the season, they can articulate that uncertainty and probability quite well. My mother, every time she crosses the road, processes a probability. She doesn't do it explicitly, and if she did, she'd almost certainly be killed. But she processes it. But as soon as you take my mother into an area where she doesn't have an intuitive understanding, she starts to process those probabilities and uncertainties in a mechanical way, and she gets lost. So we've done studies, and even where you get people in socioeconomic groups of C1, C2, which are nurses, electricians, people who are educated but aren't experts in our domain, they examined a phrase on our website which was probability of precipitation 60%. And we found that very few of them understood that precipitation was rain, hail or snow. Very few of them understood how to process the probabilities, or indeed in some cases that the word probability was associated with the word probable. Then there was a number, and then there was a percentage sign. And by the time they had got to the end of their discussion, almost all of them were lost. Now, is it their fault? Is it our fault in the way we transmit? But we've certainly got to learn to bridge. And Alan made the point about social media. And social media is it's almost as random and chaotic as the weather. And if you take the point that warnings we have to give will have to be corroborated before people take action, we also have a responsibility to make sure that there is a clear and authoritative voice which is speaking so that people can understand, and that the people who are at risk and the responding community have the same and consistent messages so that they can deliver the service and people will follow the instructions. One of the observations about Hurricane Sandy I made when compared to Katrina, where things were less well run, Superstorm Sandy, the authorities were saying, you've got to be crazy if you don't get out of your house. Now, it might be a bit American and direct for we Brits, but it was a very clear change of voice, much more authoritative, much more direct, and we have to be able to provide that kind of certainty and support to people who have the responsibility for getting people out of their homes when they're at risk. Now, in the UK Met Office, we are very often half of all the web traffic of British government web traffic, big audience. But now we have gone through a process where regularly people access our information, more people access our information through mobile media than they do through websites. And they can get it through all kinds of direct and distorted routes. So making sure that people are aware of our brand, that they understand that we are the authoritative voice, that they come to us when it really matters, is really important if the benefits of our science and our operations are really to be used effectively by those people who can benefit. And you can see some measures there. If you look, for example, at our Twitter relation, 385,000, if you have an extreme event in the UK, that can go up 50% in one day, because there is an impact that flows through the community because of the information. Knowing how to manage that is really important to us. And it's a source of pride to me that we are 17th in the top 100 social brands in the UK, because that means we are communicating through these media effectively and to some benefit. Future challenges. Well, call for improved collaboration, science and delivery. There's a never-ending challenge. There's more science. We have lots of science waiting for application on supercomputing, lots of stuff coming out that we need to communicate, and we can't do any of it on our own. Collaboration is absolutely at the essence. Continuing need for developing contextualization so that we interpret the weather and climate well for the people who need our advice. Separating politics from science. I've talked mostly about weather stuff, but all of this applies to climate science as well. And there is so much politics around climate that it really runs the risk of the world not getting the benefit of the science that we already have. I am on Wednesday giving evidence to what's called in the UK a parliamentary inquiry on the communication of climate science. So Parliament are taking it seriously, but the very fact that they have to have an inquiry into that communication means that there is scope for improvement, that there's much misunderstanding, and getting people to understand the benefits of what we have is really quite important to us. And so whilst we have in this community, and speaking personally for the Met Office, a proud history of fantastic progress, of consistent delivery and consistent improvement, to me the journey has only just begun, and we as a community underpunch the potential of the quality of work we do quite considerably. There is much work to be done and much fun to be had, I would say. That's it.
So thank you very much, John. Well, Luckily, you had just the right number of slides and the right time. Thank you very much.
I'm sure you can take a opportunity of the chief executive of the MetOffice, asking him when do you're watching. Maybe not, but please, there's some questions to John here.
Yes.
Yes, I wanted to ask about your seamless prediction slides, and you described seasonal forecasting as a sweet spot. Now, to borrow another metaphor from your talk, some people might call that the valley of death, where the science is perhaps the most uncertain, in that the initial value problem of weather forecasting is tailed off, and then the boundary value problem of climate forecasting hasn't yet begun to average out all the noise. Obviously, there's big opportunities and the need for the seasonal forecast to be accurate, but because of the current accuracy, there's a danger as well, in that, particularly with the British press, a bad seasonal prediction can reflect badly on the other aspects of what you do, which is much more certain, the weather forecasting and the climate forecasting. So how do you balance the sort of need to get accurate seasonal forecasts with the dangers of the way they're presented perhaps to the media?
Imperfectly, I think. It's quite a difficult question to answer with it. First of all, I start from the point of view that there is worthwhile science to be done here and worthwhile investment. If we were scared of doing that and publishing our results, we would never make any progress. And the progress that's made in weather forecasting over the last couple of years is absolutely phenomenal. And yet some early weather forecasters were vilified by press and others. Some of them committed suicide as a consequence of that vilification. And we have to be brave and purposeful in our investment and in sharing of our results. It gets you into a really tricky area, and with our press in the UK, we have to work really hard to make sure that the kind of limitations and progress we're making are understood. When I talk to users, there is no doubt about the value of the work we're doing, and because every little helps. If you're trying to decide how to defend the population from something, having an idea 2 months ahead is really helpful, just so you can get prepared. So it's helpful having it in 5 minutes, but it's much more helpful if you've got a suite of products and services that help you do it. So we just have to manage the doubt and uncertainty and the difficulty of communicating those messages and get better at it, whilst never ever giving up and allowing that criticism to stop deflect us from what is a massive benefit to be delivered.